this is what the agenda is. We are going to spend some time on machine learning with containers. This might be new for you if you are new to containers. So before we go ahead, can you just have a show of hands? How many of you are using Kubernetes in your environment or know about Kubernetes? Okay, excellent. How many of you are coming from a machine learning background or you do machine learning? Okay, quite a few. Okay, good. And one last question is, have you ever explored EKS or EFS? Yes? Okay, quite a few. All right. So first thing first, so why machine learning with containers? So if you look at it, container at its core, it's so container at its core is, you can make use of it at various places, not only on the cloud, but also on-prem or in other places. So you get all the goodness of containers where when you think about machine learning, you can package your training code and all its dependencies all together in a container image. So that gives you the flexibility to move around your machine learning workflow, not only from on-premise, but also from on-premise to the cloud. So you don't have to worry about all the third-party packages like TensorFlow, PyTorch, scikit-learn, and all of that. These have dependencies in your machine learning pipeline. So when you run machine learning on container, you can leverage the technology that container provides us and use it for your benefit. So what ML environment on container helps you do is it makes your workload or the containers or the machine learning workflow in lightweighted, and it's portable. You can move around, and it's always scalable. Now, why we want to run machine learning on Kubernetes. So first thing is it's very composable. That means you can create a component within Kubeflow or on Kubernetes, and you can use that in different pipelines. So you don't have to rewrite the same code over and again for different pipeline in your machine learning workflow. Second is portability, which we just discussed. You can do it on-prem today. Tomorrow you can go to cloud on AWS. You don't have to make much changes in your code, right? Because you have integrated your training scripts as well as all the dependencies in the form of an image. And obviously, it's scalable. So you don't have to worry about the scalability because that will be taken care by the Kubernetes by itself, by the architecture. So from the infrastructure side, you don't have to think about how your machine learning workflow will scale because that will be taken care by Kubernetes. And we are going to see that in the demo. So the good thing is you don't have to burn your hand on Kubernetes setting it up from ground up. So you can make use of Amazon EKS, which is our managed service. So what you can do with the EKS is basically you can create the control plane and everything will be managed by AWS. And you can connect your data nodes and you can run your workload. You don't have to worry about the patching and the version control and all of that. So we are compatible with the upstream Kubernetes, so you can always upgrade to the version of your choice, for your workflow. So everything on Kubernetes side will be managed by EKS. And the last point is the most important point. You get the goodness of the AWS where EKS gets integrated with a lot of other services within AWS, and EFS is one of that, and we are going to see that in action in the demo. So now, other thing that you might be wondering that, okay, if you are a machine learning engineer or a data scientist, do we need to write the code from scratch? So we don't have to write that all the time because we do have a pre-packaged Docker container for PyTorch, for TensorFlow, and various other third-party libraries. And what you can use is you can use the same training code, and you may want to change it a little bit and then reuse it. So you don't have to build the container images from scratch. So you can always use the pre-packaged Docker container images that we have. And one good thing is we support various third-party packages and the platforms like TensorFlow, PyTorch, MXNet, and so on. And the best part is it works. All these images works not only with EKS but other services like Amazon SageMaker, EC2 instance, EC2, EKS, and ECS, which is our container orchestration service. So before we jump into the demo, let's go into 3 components. So we already spoke about EKS at a high level. Now let's talk about Kubeflow, and then Bimal is going to talk about EFS. So why Kubeflow, what it is? So basically, how many of you have used SageMaker, Amazon SageMaker? Yeah, okay, quite a few. So if you are aware of SageMaker, which is a managed service that we have, which is basically a bunch of services that we have for machine learning. So if you want to have an ML environment where you need the flexibility to create notebooks, pipeline training, serving, inference, everything in one platform, but you want everything to run on container, on Kubeflow, then on Kubernetes, then Kubeflow is the tool. So it is an open source project, and it is kind of a machine learning toolkit for Kubernetes. So if you are a data scientist or you are a machine learning engineer and you want to run your workflow on Kubernetes, then Kubeflow is the tool, right? So you will, why I compared this with SageMaker is, if you have seen the SageMaker dashboard, you are going to see similar dashboard with Kubeflow, but the difference is this is going to be managed by you, and it may not have all the features and different functionality that SageMaker supports, but it will give you a kind of a look and feel will be quite similar to what you see in SageMaker. And we are going to see the dashboard, and you will get a good idea about that. But you can make use of Kubeflow for creating your Jupyter notebooks, deploy your machine learning workload, and all of that. And it supports all other services. So now that you are running Kubeflow with on top of EKS, you get the goodness of all these different services which we support as an integration. So we are going to integrate EFS with Kubeflow, and we are going to see a quick demo. But we support various other services like EMR, Athena, S3, EFS, and so on, right? So you get a better ecosystem if you want to run your machine learning workflow on AWS. So I'll let Bimal just share a few pointers about EFS, and then we will straight away jump into the demo. Yeah.
Thanks. Just curious, for the folks that use EKS or even containers on AWS, anybody used EFS with containers? All right, so we got a few. So let's talk about understand what is Amazon EFS, Elastic File System, and why it is what role it can play for you for your container needs. So first and foremost, in machine learning, the most important thing is all about data, right? And there's lots of data that you have to handle. So there's a need for a shared persistent environment that you can use for very various containers workloads. So the first thing is that from an EFS perspective, it is designed ground up to be simple and a cloud native. So what happens is that when you go out and create Amazon Elastic File System through your console, you just, in less than 2 minutes, in 2 clicks, if you are using one of the wizards, you can get this up and running. So there is no servers to deploy. It's completely serverless, gets up and running very quickly. The second aspect to EFS is elasticity. And the way I like to think about elasticity is like 2 dimensions, right? One is about capacity. So what happens is that in a typical storage environment, let's say if you're using storage, the first thing that you have to plan for is how much capacity do I need? Well, in case of EFS, there is no need to define capacity when you create this. So you have unlimited, petabytes of capacity that is available to you for your needs. So no planning required when you're going through this process. So very, very simple. The other aspect to capacity with EFS, which is very critical for machine learning workloads, is you only pay for what you use. So because you're not defining any type of capacity, let's say you have a terabyte of data, then you pay for a terabyte. If the workload scales to 500 terabyte, then you pay for 500. And if you want to delete it after the processing is done, then and you're back to terabyte or 0, you only pay for what you use, which gives you a great cost optimization. The other dimension to elasticity is about performance. And that is also a critical aspect in machine learning workflows. So in case of EFS, it can provide you tens of gigabytes of throughput and 500,000+ IOPS. And with the recent improvements, now the reads can be under a millisecond, which can be very beneficial in speeding up your processing, what you're doing with EFS. The third aspect to this is about integration. So EFS is fully integrated with the AWS compute constructs right from your EC2 instances and in the containers, Elastic Container Services, or even EKS, which we're going to show you today in action. There are also use cases where you may want to use this in a hybrid setup. So let's say you have servers which are on-prem and you have a direct connectivity, then you can also mount EFS to your servers on-prem as well. You would have to account for, I would say, latency in that aspect, if it's acceptable or not. But it's a great tool for just if there's some migrations or some corner use cases. Last but not least is about durability aspect in terms of it provides 11 nines of durability and 4 nines for the availability aspect of the SLA. And this is very critical because in EFS there are 4 storage classes, and there are classes called standard and standard infrequent access. In case of standard class, it can provide you resiliency for a failure of AZ. So let's say you're running your container workloads in 2 different AZs, and you have a shared storage that is available to you, and one of the AZ is affected, then your services can keep running on the other AZ. So it provides you from an availability perspective, you can design your applications through that mode. The other 2 storage classes are one zone and one zone infrequent access. So let's say if you have a workload that you want to only run within a single availability zone, then that is also an option that you can do. It also provides you cost optimization, because when you're dealing with large amount of data, cost does play a role there. So what you can do there is that either you can select a storage class based on what your needs are in terms of what kind of availability you're looking for, whether you can tolerate a failure of an AZ. So there's one way to approach cost optimization on your data that you have. The other feature that EFS provides is around in tiering. So what it can do is that if you don't know the workload pattern, you can configure to tier your cold data to infrequent access automatically for you. And there's a setting you can create either the minimum is 7 days. There are different options that you can pick. When you're defining the file system, you can go out and change it at any time. And this is very critical also in the machine learning aspect, because your data would sometimes get cold, sometimes it will become hot after a few months, and that plays a role. A good example of this that comes to the mind from a customer perspective is a use case with Johnson & Johnson. And there's a great blog there at AWS Blogs. I'm sure all of you are familiar with AWS Blog. And they articulated in terms of how they use Amazon EFS for their data workflow needs. And in their case, they had about 500 terabytes of data. So what they used to have is they had multiple projects, and every project can have, let's say, from 1 to 50 terabytes of data, and it can change. And what they were able to do with EFS was, first of all, they were able to reduce the time for processing by 35%. And the second benefit for the customer was that the reduction in the cost. So they use storage classes. They use different storage classes based on the type of data that they had. And they were able to bring down the cost about 37%. Any questions? So let's talk about how it integrates with the different compute constructs that are available within AWS. And the first we talked about, like EC2 instances, and this can be your on-prem instance as well. that you can connect. And oftentimes, like clients are, like customers, they want to modernize, right? So you're running something as a standalone within your instance, and now you want to adopt, let's say, Elastic Container Service or EKS. Then you can use the same shared file system for your needs. So this make it quite easy, and we will see today EKS in terms of how it works. And really, three things I would say one has to would be a takeaway. One is around it's highly available, a shared file system that is that's there, very simple to use, and serverless. So let's do a kind of a quick walkthrough in terms of how you would use Amazon EFS with Kubernetes and EKS, and we will show that in a demo as well, but I just wanted to kind of walk at a high level as to what are the steps. What Suman is going to do is he's going to show all this thing to the CLI, but if the way it always starts is that you start with defining your EKS cluster. So you can go to the console, you can define your EKS cluster, and once that's ready, the second step that happens is defining of the security group. So with EFS, you define a security group to open up the NFS port 2049, and then you go ahead to the EFS console, and this is where you would create your EFS file system, and you would get a file system ID, and this is what would be used for all the configurations going forward. So the way you use EFS within EKS would be through the CSI driver. And what happens is that the cluster administrator can go ahead and define and make this available within your cluster. And once that's there, the first step is actually defining a storage class. So what happens right there, you can define your storage class for, let's say, EFS here, and you would define your provisioner, which is the EFS CSI driver. And then you would provide a file system ID that you just created through your console. So you provide that. You can also provide the settings for the GID over there, and then you provide a base path as to where you want this to get mounted. From that point on, it's about straight away. This example is for dynamic provisioning. We also support static provisioning if that is desired. And in this case, what happens is that you define your persistent volume claim, and you can straight away use this in the pod. So you do the PVC claim here. This is read, write, many, in this case example, right? And this is how you can use this within your EKS environment.
Yep.
So over to someone now for the demo aspect.
Sure. So before we jump into the demo, what we are going to do is this whole demo and a lot more, we are going to touch base on that, is there in this developer zone, Amazon EFS developer zone. And I'm going to share the link for this. So whatever we are going to show now in next 30 minutes, you can do that in your account. And I would highly encourage you to do that and share your feedback. If you have any observation or if any of the code is not working, please feel free to send a pull request or just ping any one of us, me or Bimal, and then we will get back to you. Okay, so this is what we are going to do in the demo. Okay, so let's break things up. We are going to have an EKS cluster, which I have already created. So in this case, we are using EKS cluster, but it could be a self-managed Kubernetes cluster as well. So what that means is you can create, let's say, 5 or 10 EC2 instances, and you can take the upstream Kubernetes version, and you can install it and configure it. In our case, we are using EKS. Right? So you have EKS, and then we are going to use 5 node, 5 EC2 instances, and this EKS cluster will comprise of 5 node Kubernetes cluster. And we have already installed Kubeflow, right? So Kubeflow is an ML ops or orchestration software, which we just talked about, which gives us the flexibility to run our machine learning workflows, right? So we have already installed Kubeflow. But now what we are going to do is we are going to create an EFS file system. We are going to install CSI driver, which Bimal just mentioned, because by default, when you get EKS cluster or when you install Kubernetes, the EFS driver is not installed by default, right? So you need to install the CSI driver. So once you install CSI driver, you can create an EFS file system and you can mount it and make use of that storage in your Kubeflow environment, right? And in our case, we are going to do a quick image classification problem, and we are going to download some open source data set of different flowers, and we are going to train that model on this EKS cluster using Kubeflow. And the training data set would remain in Amazon EFS. Okay, so and we are going to see some other things in Kubeflow like Jupyter notebooks and all of that. All right, so have any questions at this point in the architecture or anything? Yeah, I think we have a question here. Just wait for, we have a mic, yeah.
Does this architecture need to have like EC2 instances specifically, or can we also use this with Fargate, for example?
Yeah, you can very well use with the Fargate, yes. Yeah, that's a good question. So basically, this Kubeflow, and that's the best part of Kubeflow, you can make use of it at anywhere, whether it's on-premise or on the cloud, whether you're running it on a serverless platform like Fargate or on EC2. Yeah, okay, all right. So let's go to the demo, if we can share my screen. All right, so I'm in the Cloud9. We are going to use Cloud9. Have you seen Cloud9 before? Anyone who? Okay, I think a lot of people who have not used Cloud9. So Cloud9 is an IDE kind of environment which you get on the cloud. So what you can do is you can create an environment here, and you can give any name, let's say my dev setup, and you can go to next, and you can define what type of instance you want. So what we do internally is we'll spin up an EC2 instance for you, but we also install a lot of packages so that you will get an IDE kind of environment where you can write your code on AWS. So you don't have the dependency of your laptop. So all you have to do is wherever you go, you just log into your AWS account and you can write code or ship your software, right? So that's how it works. If you go to next step, and it will just create an environment. You just have to wait for a couple of minutes, whether it's in the backend, it will create an EC2 instance and it install all those softwares. And once that is done, you will get something like this. So we have two environments. I'm going to use this environment. And if you click on Open IDE, I have already opened it in the other tab. That's why I'm not clicking on this, but I guess I have to refresh this. So let me just open it up again. Okay. So this is the environment that you get when you install, when you use Cloud9. So in the left-hand side, you have your file explorer. It's very much like an IDE if you have used any of the IDE that we have. So here we are going to run all of our code. Okay, so we mentioned that we already have the Kubernetes cluster, right? So EKS cluster. So let's see that. So if you see this, we have a 5-node cluster, right? And now what we have to do is we have to first create the EFS file system, right? So for that, we are going to use a script. But before that, I want to show you that the Kubeflow is already installed. So if you just run this, get pods, and Kubeflow is a bunch of services. And we are going to see the UI of Kubeflow in a moment. But when we install Kubeflow, it will install a bunch of different services or components like Khatib, or this is for pipeline. Similarly, for Jupyter notebooks, it has a different service. So you will see that once you install Kubeflow, a bunch of pods will get created under this namespace of Kubeflow, right? So this means that your Kubeflow is up and running. You can run your ML workflow. All right, so at this point, we have our EKS cluster ready, and Kubeflow is already installed on that, right? So now the next step would be to create the EFS file system. So we are going to use a CLI for this. Let me just show you this. So we have a code called autoefs setup.py. And let me just run this, and then I'll walk you through the code. Okay, so what this is doing. So let me just paste this, and it is going to do a bunch of operations. But before that, if you see this script took a couple of arguments. One is in which region this EFS file system should be created, and in which cluster we need to attach this, right? So these are the two inputs that we have given. And the third input is the file system name itself, which is my EFS1. So now if you look at the script, which I've opened in another tab, it does a bunch of, if you see the main function, it does a bunch of stuff. One is it checks the IAM roles and policies if it is in place, and then it sets up the CSI driver. So this is a one-time activity. So it will just install the CSI driver on your Kubernetes cluster. And we can see that in a moment. Once this script gets over, I'll show you how you can see the CSI driver component in all the cluster nodes. And then it is going to create an EFS file system, because without CSI driver, you cannot create a storage class on your Kubernetes cluster, right? So because you need to make sure that you have the driver installed. So this script is doing that CSI driver installation, and after that, it is going to create that file system. And once that file system is created, it is going to create a storage class, right? So in Kubernetes, for dynamic provisioning, what you have to do is you have to define a storage class. And in that storage class, you will mention the file system name, right? So let me show you that. So now that I guess the script is almost done, or it's already completed. Okay, so now, if we go to our EFS dashboard and go to file system, you see this, there is a file system already got created, and it got created just now, sometime back. So now if we go back here, and if we see this, kubectl get sc, which stands for storage class, you will see there are two storage classes. One is GP2, which is the default storage class you will get when you create an EKS cluster from our EBS volume. And then this EFS-CS, this is the storage class which this script created. Now, if you want to see the YAML file for that, we can see that here, I guess. Yeah, so we can see that here, that this is the storage class which we have created, and this is the file system ID, which it has created, in our EFS on the EFS side. If you see this, last two digits are 7D, and it's the same, file system, right? So now we have a storage class ready, and it is connected to our, our Kubernetes cluster. So now let's go ahead and create a Jupyter notebook and do our machine learning training, right? So for that, we need to open the UI of the of Kubeflow. So for that, we have to run this service, stlo, and now we should be able to open the UI. So I'm just opening it up in a different tab. So it should ask you for username and password, but since I've logged in a couple of times, it did not ask. But if you now compare this dashboard with Amazon SageMaker, it's kind of look and feel is kind of same, right? So you get pipeline, you get Jupyter notebooks and all of that. It's not that exhaustive as SageMaker, because SageMaker has a lot of different functionalities, but you get the idea, right? So now what we can do is we can come to this volumes, and we can create one volume. So now let's say this is the volume which I want to create, where I want to keep all the training data set for my ML training, right? So we can name it as, let's say, data set. And here we can give the class, since we have two classes, so we can select EFS SC, and we can give some capacity of 100 GB or 200 GB. It doesn't matter, because as Bimal mentioned, EFS, you don't have to mention size, so it will scale up or down based on your data. But still, to make Kubernetes happy, we need to give this volume size. And here you can get a couple of options like read, write once, and read, write many. So since EFS is a shared file system, you can select read write many and create this file system, create this volume. Now this volume is in pending stage. That means this volume is not being used by any of the application yet, right? And the reason is for this is, if you see this, let me go back here, and if you run kubectl get storage class, if you see this, while we created this storage class using that Python script, we used this volume binding mode as wait for first customer. And what that means is it will not create that PV unless or until you attach that volume to one of your application or pod in our case, right? So that's why it is still has not created any volume, and that's why it will always remain in this pending stage. So let's try to make use of this volume in one of our Jupyter notebook. So let's come to notebook and create a Jupyter notebook. We can give any name, let's say notebook. And here, what we can do is we can add an existing volume because we have already created that volume. So let's give this name as data set because this is the volume we have created, and then click on launch. So now what Kubeflow is going to do is it is going to create the Jupyter notebook, and this notebook is also will be created in a pod, and then it will attach that volume to this notebook. And once that is attached, then we will see that volume in our EFS console as an access point. So it will take some time, but now if you go to EFS file system, click on this, and inside access point, you see this access point got created just now. Okay, so this is access point. You can think of it as the entry point for your application on EFS. So you don't have to create multiple file systems for different pods. So today you have created one application which is using its own storage, so it has created this access point. But tomorrow, if you want to run another workload which needs another storage, you just mention how much storage you need, and it will create another access point. So you can keep on creating access point within your file system. Okay, so you don't have to create multiple storage class. Yes. Yeah, we have a question. Can you just get the mic, please? Yeah.
Check. So I noticed, Simon, when you provisioned the storage, it gave a default choice of EBS.
Yeah.
So I'm just wondering what happens when you select that, and how is this materially different than that? What you've just done? What is the benefit of selecting the EFS versus the EBS choice?
Excellent. I think that's a great question. So this question is, when we have multiple storage class and the default is EBS, when to use EBS and when to use EFS. So now if you see this, we have created this notebook. So now this notebook has created as a pod, and it will use its own home directory. So that was created on the default storage class. So in this case, if you see here, so let's see that in action. So if you now come here and see kubectl get pod, and I guess namespace is PVC. Okay, let's run this. There will be a lot of pods. I just want to know the pod name. Okay, so this is our notebook, right? So this is our notebook 0. Okay, so now if you see kubectl get pvc -a, you will see that it has created its own, the home directory was created on a volume from the EBS. And the reason is because we have in the storage class, kubectl get storage class, the default is GP2. We can always change this default to EFS. In that case, when you create any workload, when you create a Jupyter notebook, or if you run any workload on this cluster, it will use the storage from EFS. And the benefit of that would be you don't have to manage that storage. In this case also, you don't have to manage, but EBS has a limitation in terms of size and capacity, right? So you might get an error that, okay, this storage class like GP2 is exhausted, so can you create a new storage class because the storage is exhausted. But in case of EFS, that limitation you will not find. But when you create an EFS-based storage class, you can always change that to default storage class. It's not like you cannot change it, right? So there is a command called patch. So I guess if you, I'll not run this, but yeah. So this is the command. So kubectl, if you see patch, and then you have to update the metadata of default storage class from true to false. That's the only thing, right? So in this case, GP2 is turned into true. So that means that I must have turned it to false before running this command. Okay, so you can always change that. All right, so now if you come back to the dashboard, this notebook is ready, and now we can get inside this Jupyter notebook. And now you will see that dataset directory. And this is coming from our EFS file system. And inside that, we don't have anything, right? So we need to download the dataset first. So let's quickly do that. And we can create a Jupyter notebook. And I have the URL to copy the dataset. So let's quickly do that. So what this 4 lines of code would do is it is going to download open dataset for different flowers. And after that, what we are going to do is we are going to run a training job from Kubeflow, and which will act as this training dataset. Okay, so let's give a couple of minutes, but in the meantime, we can show you what is coming inside this. So if you see this, under this dataset, we have a flowers underscore photos. And inside that, we have different flowers, rose, sunflower, and so on. And if you open this up, you have different flowers, right? So these are the data set which we are downloading. So it is still running. Let it run for, I think it will take 1 minute or so. And then what we are going to do is we are going to start a training. So let's just revise, where we are at this point. So we have created this EFS file system. And we have installed CSI driver using that Python script. And then we have attached it to our Kubernetes cluster. And that cluster is using that as a storage class of EFS. And now we have also downloaded the dataset on this EFS file system. So the last thing is we need to push the training image to our repository, which I have already done it on ECR. And now we just have to run that script or run that machine learning workload on Kubeflow. So let's go back and let's wait for this. I think it's completed. All right. So this folder called dataset contains all the training dataset. So that means if I now run any application and mount this file system, it should be able to read the whole dataset, right? So we can close this tab because we don't need that anymore. And now let's go back to our code and let me show you the Docker image. Okay, so this is the image I have in my repository, right? So this is the image that I already have, and I have pushed it to my ECR repository. And now we can run the training script. So before we run that training script, I want to show you the TensorFlow training job file. So if you see here, so this is the ML job that we are going to run, and it is going to be an image classification problem. And since we have installed Kubeflow, we can say that the kind is a TensorFlow job. And we are going to use 2 replicas. That means when we run this job, you will see 2 pods getting created. And this is the interesting part. We are going to use this volume called dataset, and we are going to mount it under training folder. That means this training job will create a container, and it is going to have our training dataset under this training directory, right? And now if you go to the script itself, which is the TensorFlow script, you will see that we have defined that data directory, which is our training dataset directory. as training_flowers_photo. Training/flowers_photo, because this is the folder, if you remember, we have downloaded, right? So, and it's a very simple CNN network. We have some convolutional network with a max pool. If you are into machine learning, these things will be familiar to you. But we have not done this extensive training. We are just using 2 epochs, but the idea is to show you how you can run your ML workflow. So let's go back and run this training job. Okay, so let me just run it. So if you see this, the training job got created. And now if you see the pods for this training, you will see that there are 2 pods got created, and they all are running. So let's see what's going on inside one of them, right? So we can go to any one of them. So we are going to the first one. So it is still a creation phase. And now we can actually see the logs. So let's go to the worker 0. So let me clean the screen and run it. And if you see here, the training is now going on. And we have, in the script, we have mentioned as epoch 2. So what epoch is in machine learning, so let's say if you have a training data set, and if you run the training for 1 epoch, that means that it will go through all the images of your data set only once. And whatever it, whatever function at the end it creates, it will be your final model. But if you say that epoch is 2, in that case, it will go through all your images once, and then again, it will go through all your images. So it will go through your images twice. So you will get a better model. So similarly, if you have epoch 3, 4, 5, you will get a better model. But obviously, beyond a point, your performance or the, percentage accuracy will not increase, right? It's like if you give me a book, and if you tell me to read the first chapter, I can mug that up in maybe in 5 reads. But after that, my accuracy, my efficiency will not increase, right? So if you see this now, we have completed 2 epochs, and training is done. And we did not get a better accuracy. It's just 52%, which is okay, and which is obvious because our training data set is very small. But I just want to show you, how you can make use of Kubeflow to run your ML job. So now if you see the pod, it was in ready state, but now it is in a not ready state. So it's already over. So you don't have to pay for your compute resources at this point in time, right? So I think that's all I wanted to show you. And before we wrap this up, you can always delete this whole training job by by kubectl delete, and that job will get deleted under the hood. Okay, so that's all about it. And if you have, okay, one more thing I wanted to show you is where you can get those code. So this is the Amazon EFS developer zone, right? So in this GitHub repo, if you come, and this is under AWS samples, and inside that, if you scroll down, you will see basic information about Amazon EFS, if you are new to that. And then it will also talk about various other integration, right? And this is what Bimal talked about, how you can make use of EFS with various compute services, not only on container side and EC2 and on-prem, but also with SageMaker. An important thing to note here is you can access the same data at the same time from all these compute resources. It's not like one or the other. And now if you scroll down, you will get some recent announcement, which Bimal spoke about briefly about the sub-millisecond read latency. So you can get all the updates here. And now if you just scroll down, you will get all these tutorials or workshops. So, so the idea of this page is you don't have to hop around different places to see or build your application. So in this case, we checked Kubeflow, which comes under container. So you can see that you have a machine learning at scale using Kubeflow. And now if you click on this and open this up, you will get step-by-step guide of how you can set up this whole environment in Cloud9 instance. But you can very well do it in your laptop. But if you want to set this up in your account, feel free to do so. Right? And if you have any advice or any suggestions or inputs, feel free to send a PR request. We will have a look into that. Okay, so with that, I think we can go back to the slides. And if you have any questions, we'd be more than happy to take it. Yeah, I think we have a question here.
Hello.
Yeah.
So you mentioned with the latest announcement, we can connect to on-prem data sources as well. And I wanted to know, suppose that I am running two applications. One is on the cloud in a separate EFS instance, and then there is some data on-prem. Can my Kubeflow basically cluster connect to two different data sources? Can I mount two data sources onto on a single cluster?
Okay, so so let me understand your question. So your Kubernetes cluster is on the cloud, is that correct?
Yep.
Okay, is it an EKS or
Yes, it is an EKS.
It's on EKS? Okay, great. Now, what you are trying to do, you are trying to attach the storage from on-prem.
So I have two storages. I have one distinct application which is on EFS already on the cloud.
Okay.
And I have another data source which is on-prem.
I see.
So basically, what I'm trying to understand is how do I merge the two data sources, and can I use both of these data sources in one EKS cluster?
And is that around, like, you want to merge permanently, or is it one time? What's your plan? Like, do you want to move the on-prem data set to the cloud? What's your kind of long-term thinking there?
If it's a long-term thing, I would essentially move the data source to the cloud. But if it's just a one-time thing, how would I go about that?
Yeah, so we do have several migrations utilities and their services that would help with that. So for example, you can use data sync. So data sync can be used in this scenario. And what it will do is that you can provide, let's say, a file server, which is on-prem, as your source. And you can schedule like a migration, so you can copy your data over to EFS. And you can provide any target. So even if you, let's say, want to provide as a S3 or EFS, those all choices are available. So data sync is a great option to do that. It also supports, for example, there's a new announcement that just came out. If you have a Hadoop environment and if you want to migrate some of the data from there, then there's a new capability there as well, which will do that. So data sync is one of the many tools that you can use for that kind of migration. And you can also do it like a scheduling also. So let's say you want to move once and every so many months you want to push it, then the service has that capability to do that.
Right, so I use data sync to move it to the same EFS instance and then use that.
Yes, if you want the second application, let's say, is connected to the to the EFS, and that's where you want to target, then you can do that, and then within your cluster, you can take advantage of that.
Thank you.
So in the demo, you actually showed us how to provision a new EFS instance and connect the pod to that.
Right.
So I'm going to assume from what Bimal just said that you can actually provision an existing EFS with data in it to your pod, and the Kubeflow will support that.
Yes, that's correct.
Yeah, so just to add to the question, right, can you use your existing EFS file system? So the way in EKS, the first thing you have to do is when you define the storage class, this is where you would have to specify the file system ID. In our case, in demo, we created this to begin with. But let's say you already have a EFS file system out there, then just get the file system EFS ID, and this is where you would specify, to your question, an existing file system.
Yeah. And just to, as a follow-up, is we use dynamic provisioning. So let's say you have your data set already in your EFS file system. You want your pod to access exactly that access point or that file system. In that case, you may go with static provisioning, where you just mention which file system, which folder directory structure, and it can use that for your training. But yes, you can always use, and that is what our customers does. They don't create a new file system with new data. They already might be having that data set. Might be that data set is coming from S3 or somewhere else, or from your machine learning pipeline, and then you consume it in Kubeflow in your ML workflow. Yeah, that's a good question.
And one thing to add to that is that the CSI driver for the EFS, it's an open source driver. So if any of you would love to add to that and contribute, please go ahead and do that. You can go out, take a look at the code, and we are always welcome that feedback from our customers.
Yeah, I think that's a great question. I mean, this is very important because few of our open source project, we are actively working on that, and CSI driver is one of them. As we are speaking today now, we have from our team member from the CSI team speaking about CSI driver at KubeConf in Spain that is running now. So feel free to contribute, even if you are not a developer. If you want to have some idea or some use case which you feel is not supported as of now, feel free to raise a PR request on an issue so that the team can look into that. Yeah. Okay. So anything else? Any other question, or we can see this.
Like any other questions in terms of the use cases that you have right now going, within your environment?
Yeah. Any questions in general, if you would like to ask, we'll be more than happy.
I know it's second day and it's that time of the afternoon, but
yeah. All right. So this is the place that we should go. You can find all the tutorials. We have seen this, and we have launched this, I think, early last month. So feel free to have a look into this. And this is also, if you have built something and if you want to, share that with the community, feel free to raise a PR request so that I can, check that in.
Yeah, and I think we should also talk about
Next slide.
This is a great program. Is anybody familiar? Have you used Skill Builder on AWS? Has anybody tried it? Great. So we have some. So Skills Builder is we have a training available for free for customers. So you can go out and you can pick up a track. And you can get now, from a storage perspective, we added like badges. So all of you are probably familiar with the AWS certification. So we just started, we felt like there's a lot of different storage services. So what we have started to do now is that there is a whole track out there for object right now. And once you finish that, there's a small test that you will go through. You can do it as many times as you want, and it's free. But once you complete that, you earn a badge. So you earn an object badge. And there's another one for block right now, and there's one that will be coming up for file. And we highly encourage all of you to just go out and take it. It's another kind of feather in your cap. The plan is that you would go through, you earn all these badges, and that will earn you like a storage badge at the end. So there's a whole program around it. So please go ahead and you can scan the code. It's free of charge. Please let your colleagues know. Give us the feedback. What else would you like to see? But something to go out and try.
Yeah, sure. Okay. All right. So thank you so much for all your time. Feel free to reach out to us, in social media or wherever you feel like. If you have any questions, we'll love to take that offline as well. Thank you so much for your time.